Okay, we're still looking at lesson 9-7. It says real world data seldom falls exactly into linear, exponential, or quadratic patterns. So we might get really close, but they're not going to be exactly like we would with the made-up model. So however, you can determine which type of function represents the best possible model for the data. So let's look at example problem 3, modeling real world data. Transportation. The data at the right give the value of a used car over time. Which type of function best models the data? Write an equation to model the data. So here, my years, the first thing I'm going to check, like they did here, is to make sure that my x value has the same increase amount. So we are increasing by 1. And then for value, they looked at common ratio first, and they looked up, and that was the one that it came up to. So for common ratio, you just divide. So it's going to be 11,065 divided by 12,575, and so on and so forth. And it looks like it's around 0.88. So from using that on that first page, here is the exponential function that we're using. A is the initial value, and that was 12,575, and B is the decay factor, which is 0.88. And so my equation will be y equals 12,575 times 0.88 to the x power. And then okay, so that was it. So now there's testing. So they're testing to 2 points. So they tested 2 and 9,750, and they tested 4 and 7,540, and they just plugged into the equation that they have, and they got about the point that they want it to be. So this is really close to 7540, and this is really close to 9750. So that makes this equation pretty accurate. So let's look at guided 3 to see if we can do it on our own. So the table shows the annual income of a small theater company. Which type of function best models the data? Write the equation to model the data. So I've written it here on my whiteboard. And again, first thing I always want to check to see if my x values are increasing by the same amount. And they are. They're all increasing by 1. And so the first thing that I'm going to check using subtraction first. So we'll do 18,254 minus 18,730. That gives us 476. So we'll put plus 476. We'll do the next one. And so I have 18,730 minus 19,215, and that's 485. Oops. Let's do the next one. That's going to give me 19,215 minus 19,695. It gives me about 480. And then the last one is 19. And you can actually flip them around. It might be better to flip them around because I am putting that I am adding. So to get from here to here, I'm going to have to add. And if I want to actually find the value, I will have to subtract. So it will be 20,000 minus 175. And that's why my values are coming out negative, and they should be positive because I'm doing it in reverse order. But we know that we're really adding. So it looks like they're all around 480. So I'm going to say that this is a linear function. So since this is a linear function, and it makes sense, we're talking about the income of a theater company over the year. So it's probably not going to increase exponentially. That might be a little too much, but it will increase linearly. So that does make sense for what we're dealing with. So we'll go back to our box. And we know we're looking at y equals mx plus b. Where m is my slope, and I'm going to use just this 480 as my slope because that's my change, my rate of change. And my y-intercept is the place where it crosses the y-axis. Okay, so there's the equation. And we can test some points to see if we get about that amount or close to it. So let's test this point here. So y equals 480 times 2 plus 18,254. So let's put that in my calculator. So 480 times 2 plus 18,000. I'm not going to remember that. 254. And I get 19,214. Let's look at my chart. And it's 19,215. Pretty close. We can check one more just to be on the safe side. So we get 19,214. And let's try this point here first. Y2 equals 480 times 1 plus 18, 730. So I'm just going to go ahead and do that. I think that's what it was. Yep. And I get 19,210. Oh, I'm sorry. That was, wish the student was here to say, Miss Kate, you put the wrong value. And this is actually supposed to be 18,254. So let's do that instead. Sorry about that. So it's 480 plus 18,400. 254. And that gets me 18,734. Let's look at our chart. Yep, 18,730. So that's really, really close. So this is a really good equation to use. I hope this helps.